All right, everyone. This is us going through the 6.1 quiz here. So, question one, we have a distribution. Um, in some of these, you might not have to read the whole problem. Sometimes you might want to. But I see it's a distribution. I jump to the answer, and it says, what is the expected number of cars in a randomly selected household? So, I'm just going to go right into my stat um, and edit my lists. So, we're going to get 0. Alright, so it's in my list now. I just go stat calc 1 var stat L1 to L2. Calculate. Boom, my mean is 1.75. Remember, mean and expected value are the same thing here. So what's probably that a random number gets what's probably that a randomly selected subject plays with at least 3 toys. So that's 3 or 4 or 5. And so notice when we're looking at the distribution, there's nothing for 5. So I need to find that distribution here, or find that probability really here, real quick here. Sorry. So all the probability should add up to 1. So I could do 1 minus 0.03 plus 0.16 plus 0.3 plus 0.23 plus 0.17. That is what 5 is. So 35 is 0.11. So now at least 3, that is going to be 3 or more. So 0.11 plus 0.17 plus 0.23. And that is 0.51, which is the correct answer there. All right, there's a lot going on here, so we'll take a look now. In government data, a household consists of all occupants of a dwelling unit, while a family consists of 2 or more persons who live together and are related by blood or marriage. So all families form households, but some households are not families. Let H equal the number of people in a randomly selected U.S. household, and F equal the number of people in a randomly chosen U.S. family. Shown below are the distributions for household size and family size in the United States. So families can't have just one person. There has to be multiple people for it to be a family, but the household could be a single person living on their own. So here they are. Here's our distributions as well. It says which of the following is true. The variability of the household distribution is less than the variability of the family. Since it doesn't tell us what variability measure to use, the easiest one to look at is range. You can also say this doesn't have anybody in one, so it goes from 2 to 7 or a range of 5 versus the other one has a range of 6. So family range is 5 while household range is 6, so that one's obviously not true. The mean of the household distribution is less than the median of the household distribution. So household right here, we see that this is skewed right, which means that the mean is going to get pulled to the right. So it's not going to be less than that. It's going to be more than that. The event x equals 1 has a much lower probability in households. So let's do probability that family equals 1. So family 1 is 0. versus probability that household equals 1.32. The event X has a much lower probability in households than it does in family. That's just not true. Both distributions are skewed to the left. All right, they're both skewed in the same direction, but skewness in the direction of the tail, so they're both skewed right. Which means, here we go, the center for the household distribution is less than the center of the family distribution. And I'm sure if you plug these in to your calculator and calculate the median or the mean of both of them, you would get that out. But we don't necessarily need to because of process of elimination. All right, so that's number 3. Moving on to number 4. How does your web browser get a file from the internet? Your computer sends a request for the file to a web server, and the web server sends back a response. Let y equal the amount of time after the start of an hour at which a randomly selected request is received by a particular web browser. The probability distribution of y can be modeled by a uniform density curve on the interval of 0 to 360. So 0, 3, 6, 0, 0. And we know it's a uniform density curve. Boom. What's the probability that the request is received by the server within the first 5 minutes, or what is 300 seconds? So it's in the first hour. Doesn't matter. So we're looking for this area. So the big thing is trying to find the height. Remember, the area of that equals 1, which is base times height. I have my base of 3,600, so my height is just going to be 1 over 3,600. So to find the height of that new rectangle, it is going to be 1 divided by 3,600. That times my base, which is 300.083. And number 5, choose an American household at random and let the random variable x be the number of cars, including SUVs and light trucks they own. Given is the probability distribution if we ignore the few households that own more than 5 cars. About what percentage of households have a number of cars within 2 standard deviations of the mean? So I got to find the standard deviation here. So I'm going to go back to my list. Thankfully, my data is already in there. It looks good. So when I go stat calc, 1 var stat, yep, all good there. L1, L2. My mean is 1.75. My sigma is 1.081. So about what percentage of households have a number of cars within 2 standard deviations of the mean? So I'm going to take that 1.081 times by 2. So I'm going to take my 1.75 plus or minus 2 standard deviations, which is 2.162. So that would give me 1.75 plus 2.162 and minus. So I'm going to allow my x to be between negative 0.412 and 3.912. So what probabilities fall in there? Well, 0 does, 1 does, 2 does, and 3 does, but I don't get up to 4. So I'm going to add up those 4 probabilities. 0.09 plus 0.36 plus 0.35 plus 0.13, 0.93. Alrighty. And that is 6.1 quiz.